model is usually integrated for less scalability handling large data set, and we call them hierarchical clustering. And we can use centroid model. Centroid model, okay, is actually where the similarity is derived as the movement closest to a data point in the cluster center. That means to say that we have to determine, let's say there's a big cluster there. We look at the center point of the cluster and we see how close are they. So that's why we call them K-means. Okay, K-means. So we call them, so the centroid model is called the K-means. So how many clusters is mentioned in the one? You can bring 4 clusters, 3 clusters, as I told just now, right? And so you have to know some knowledge about this data set. Distribution model, what is the likelihood that all the data in the cluster belong to the same distribution? And this is what it calls statistical distribution, right? Using the normal distribution curve, right? Overfitting is common, right? So that's why expectation maximization of volume. Density model, right? It isolates the various density region and assign data point in the same cluster. The DBSK. We'll do this in the next session. So, simple way of factorization is FAT algorithm. FAT algorithm, we start with random partitioning, and then we test that K-mean clustering until we find them together. Hierarchical is actually using bottom up. So I told you that let's say 6 point A, B, C, D. We try to group the 2 points together and then add them up together. And that is what is called algorithmic. Okay? And there are many others, right? So today we will focus on K-means, right? So actually the algorithm here, you don't need to know why, because the algorithm model will calculate it for you. It will calculate it for you. Right? So you can see here, right? Here, the K-means. This double scan is here, PCA is here, and then okay. Okay, so what we do, we generate the algorithm, right? That means we find how many clusters are there. First, we're going to pick K data point and a set of cluster center at this point, right? Then after that, we randomly generate a center point. We take the mean of the cluster, find the average. Then after that, we find the cluster center that is closest to some distant measure, and then assign the data point to this Okay, then you recompute the cluster center of each data in the cluster. So you reassign until there's no more. Stop when there's no more reassignment, right? You terminate. So when do you stop? Well, you have finished three different numbers of iteration, right? That means you try again and again, you finish that. Or the cluster doesn't change for any data entities, that's why you stop. Or the clusters, this is the cluster locations are not changed. And the cluster center also don't change, right? So that is how this is actually aimed at minimizing an objective function giving user a square error function, right? So the step is one, given a set of data x1 to x, right? And then the set of data point v1 to vc to be the center set of the center. Then you randomly select a C cluster center inside here. Select any one. Calculate the distance between each data and the cluster center. Then you assign them, right, is the new all cluster sample, and then you do the calculation and recalculate until no data point was reassigned, and then you stop. Okay, and reset tree. So you can see here, right? This is the K mean. So K equals to 2 means you say that there will be two clusters. Okay, K equals to 2 is a two cluster, right? So that's why we see pick the seed. These are the seed, red dot, and the blue dot are seed. Right? Then after that, you will see that okay, this so K equals to 2 means I form two cluster. Right? Then after that, I compute the centroid. Okay, that means I find the center point. Okay, the center point is here for the red one, and for the blue one, the center point is here, the X is here. Right? Okay, after compute that, then after that I will assign. Okay, and see the distance between these the circle and the center point. So I assign here as 1, and here they all convert as 1. So that's why we convert this part here, so this is one conversion, and this is another conversion. Okay? So over ask yourself, right? How many clusters do you want? So in this case, let's say for example, we want 5. We have 1, 2, 3, 4, 5. So K is 5. Okay, if you want 5, K is 5. If you want 2, K is 2. Right? Then after that, you guess the K cluster center location. So you can make a guess. Where is the center? Right? Here, 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 or here. Right? Okay. So you have to randomly guess now. Okay? Then you find the data point that is closest to the center own set of data. Okay, there you are. So I find data point which is the closest. So I find that 1, 2, 3, 4, 5. Right? Okay. And then this center will find the centroid that we own. Then we find the center for this part here is here. The center for this cluster 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 is here. Okay. So the center will find the center with the own. And then jump there and repeat everything again until it's terminated. Okay. So first start, that's what we do. Okay. Then after we move. Okay. So it depends on where the center is. Okay, then we calculate and readjust the cluster for start. And continue readjusting them. You can see that it's here. Just now the black color point is here. And after adjusting, it will come here. But just a red color point is here. After adjusting, it will come here. Right? Okay. And then after you move again. Here. Now it's better now. Right? Now the alignment is better. And continue and continue and continue until we get the right point. And then we terminate. See here now? Right? So we see that it converged. Right? Okay. It converts that the black point, all the points should be there. The purple, all the points should be there. And the green, all the points is there. And so in this case, we have 1, 2, 3, 4, 5 clusters. Okay, in this case, we have 5 clusters. Right? So it means it's an algorithm that classifies or group the object based on features in the k numbers of groups. Okay, based on one particular features, right? And so k is a positive integer. Okay, and the group is done by minimizing the sum of the square of distance between the data and corresponding cluster centroid. Okay, this is how the algorithm works. How many clusters you want? Then we find the center point, roughly find the center point, and then calculate the distance of each point to the center point. Then we group them based on the minimum distance. Okay, so if there's no object in the group, then you move the group. Okay, then you move the group. It's not easy the group move, right? Okay, this one, they move here, move there, move there. And finally, you end them. So that is how the K-mean algorithm works. Okay, so step one, you give you a decision on the values of K. How many clusters you need. And then partition them into K cluster. Okay, then after that, assign, put in the sample value randomly or systematically as follows. And then you take the first K training sample as a single element cluster. Then after that, you take the next one and the next one and the next one. And calculate the nearest to the centroid. And recompute them until they're closing together. Right? Then after you compute away the distance from the centroid. Okay, so if this sample is not in the cluster with the closest centroid, then switch this sample to the cluster and update the centroid of the cluster, right? And move them. Then repeat step 3 until it's converged. That is until pass through the sample that is causes no new assignment. Okay. So implementation of K algorithm using K equals 2. So we have here individual 1 to 7. Okay, we have variable 1, 1.0, variable 2, 1.0, individual 2, 1.5, and 2. Okay. Then after that, okay, you want 2 only, right? So maybe we just take 1 M1 equals to, okay, here, 1, 1. And M2 is equal to 5, 7. Huh? Right, 1K, 1K equals to 2, right? So we pick a center point, a centroid. Oh? Put a centroid here, maybe 1, 1 and 5, 7. Right? Okay, 1, 1 and 5, 7. Why we pick 1 and 4? It's up to you. Because we only want 2. Okay? So we pick something in the start and something at the end. So it means individual is 1 and the group 2 will be 4. So there will be 2 groups. K equals to 2, so there will be 2 groups. One group individual is 1 and the other one is 4. So the green vector for individual 1 will be 1, 1, 1, 1. Okay? For this 4 will be 5, 7. Right? Then after that, we calculate the 2 clusters. Right? So one cluster is 1. So you see here, 1, 2, 3. So one group, 1, 2, 3. 4, 5, 6, 7, another group. Okay, so we classify 1, 2, 3, one cluster, 4, 5, 6, another cluster. Okay, so far? Of course, in the item they will calculate for you. It is just to make you understand how to work the song. But then after that, okay, 1, 2, 3, then you do the average, the mean, to find the centroid point. Right? The mean to find the centroid point. Right? So 1 plus 1.5 plus 3. This one will be 1 plus 2 plus 4. Okay? And then divided by 3 because there's 3 points. Because there are 1, 2, 3, so there's 3 points. So you find the point here. 1 plus 1.5 plus 3, 1/3. Find the mean is divided by 3, there's 3 points here. Right? So the centroid for this one will be 1.83. And the centroid, okay, and 2.33. The centroid for this one, take, right? Okay, we take 5, 3 plus 3.5, 4.5, 3 plus 3.5. Okay, that 4 there, so divide by 4. This case here, we take 7 plus 5 plus 5 plus 4.5 divided by 4. There you are, 7 plus 5 plus 4.5. I think there's an error here. Okay, there's an error here. Yeah, so it should be 2, 5 here. Okay, so don't ask me why 1, 5. There's an error here. It should be 2, 5 here. Okay, Ken, Nick, hello, Nick. Okay, there's an error there. Okay, 这有一个错误哦，2个5哦，okay, because there's to be 4 number. There should be 4 number. So in this case, 5 plus 3.5 plus 4 plus 3.5. There you are. 5 plus 3.5 plus 4.5 plus 3.5. That will be 7 plus 5 plus 5 and 4.5. Okay, and that will give you 5 points. And so therefore, this, so you have to get, so now you know the two center. One is 1.8, 2.23. The other center will be 4.12 and 5.38. Right? Okay, so that is getting the new center. And now is to find the distance. Okay, the distance M1 and M2. M1 and M2, the distance between the point and the centroid. So we have the centroid now, we enter the mean. Now we find each particular point and find what is the differences, right? So, and so what we do is that we take 1, so for minus 1.5 square plus 1 minus 2 square, and that will give you 1.12 here. That will give you 1.12 here. Okay. Okay. Yeah. 1 here. Okay. 1.5 here. 1, 1.5. Okay. 1, 2. 1, 1.5, 1, 2. Okay. 1 minus 1.5, 1 minus 2 square. And that gives you 1.12. So therefore, we get 1.12 here. The next one, we find the centroid again. Okay. And we take 5 minus 1.5. Because we take this is 2. Means we take here. Okay, this is 2, so we take here. And measure the distance between them. Between, okay, here to M1, and the distance between here and 2. Understand? So we measure the distance between here to here and distance between here to here. That's why we have 5 minus 1.5, right? And then 7 minus 2.0. Okay, and so therefore, in this case here, we got 6.10. Okay, 6.10. Okay. Now, after finding that, using this centroid, we compute what we call the incident distance of each object shown here. So you can see the new cluster will be 1, 2, and 3, 4, 5, 6, 7. Just now was 1, 2, 3, right? Just now was 1, 2, 3. 1, 2, 3. But now after calculating, right? Now it becomes 1, 2, and 3, 4, 5, 7. Okay. So you can see the 3 here has now moved to the other cluster. See the 3 here after calculating this, right? Okay, then you get this value, right? And then you see that this 3 here has been moved, right, to 3 to the 3 here. So the new centroid now will be, now after that you get the new centroid. Now you find the mean again. Okay, you find the new centroid again, and then find the new centroid for here. Okay, you find the new centroid. Now we'll calculate again. It's the same thing. You calculate the new centroid for. Last time was 3, 4. 3, 1, 2, 3, 4, 5. Last time was 3, 4. Now it's 2, 5. Okay, just now it's 2, 3, 4. Now it's 2, 5. Then you calculate again, the centroid again, right? And then, okay, then you do the whole thing again, and you can see that there will be no change here. Okay, it will be the same. There's no change here, and therefore the algorithm will come to a stop here. And the final result will be that there are 2 clusters. One is 1, 2, and the other is 3, 4, 5, 6, 7. So this is how you calculate again, and then you see that it is 1, 2, and 3, 4, 5, 6, 7. And then you can plot here 1, 2 is here, and 3, 4, 5, 6, 7. Okay, 3, 4, 5, 6, 7 here. So you have one cluster here and another cluster here. So 3 is nearer to this side than compared to this side. That's why we move. Understand? So you you can see this point 3 here, which is actually much more nearer to this centroid rather than this centroid here. That's why 3 move up. Okay, when 3 move up, that's why 3 is move away from this centroid. Right? So therefore now, so just now we talked about k equals to 2. Now we'll talk about k equals to 3. Same thing here. Okay, I'm not going to calculate again. Same thing. Okay, now we take k equals to 3 and then k into 3 cluster. Right? So we take 1, 2, 3 here, right? And then follow the same thing. Then if you follow 3 cluster, okay, maybe this is one cluster, this is another cluster, and this is another cluster. Right? So you can see that you move, you find your k, right? That's now k2. So I group these two together. So these two are nearer here, right? These two are nearer here. So I group these two together. But now we put it to 3, and we find that these two are further away. So that's why we got 3, okay, and so on. So that is how the k means work. Okay. So the property of k means to say that it guarantees to converge. That means it will go nearer and nearer to the centroid, right? And it guarantees to achieve the optimum, not necessarily global optimum. Okay. The flow is low complexity. Okay. And gives the best result. Con is you must know what is k. You must try. Okay. But don't forget what happens if you have some data that is so far away. And that will affect the result. That's why when you do data cleaning, you have to find the box plot. You find the box plot already, then this outer data is to kill it. Okay, that's the purpose of data cleaning. Okay? Okay, when you find the outer data, that will affect the result. It might affect the result. And so therefore you need to take it away. Right? That is the purpose of doing R statistics, right? You find out all those things that you don't need it, like zero, there will be some noise, that will affect your data really. So for IV, you can use Excel and do it quite easy, right? But for here, you can use Python. But if IV you're not good in Excel, you use Python, I'm okay with it, right? I'm okay with it. But what research say that the IV has no data, okay, fine. Okay? So it's sensitive to noise and outer data point. So this out here, I told you right, if you learn these statistics, it could increase your mean value, right? Okay, height of a student here, 1.6, 1.4, 1.5. And all of a sudden to 110. Your mean will not be 1.2, 1.3, your mean will become 6 or 7, So that's why the issue is about. So clusters are sensitive to initial assignments of centroid, right? Not a heuristics algorithm. It can sometimes be inconsistent from one run to another run, right? I mean different now. Okay? So that is the K-mean cluster something. Mm. Okay, there you are. So I'm running here, right? So you can see that this is a clustering algorithm even in your study guide. So you can see that there are 3 here, right? 3 points here, 1, 2, 3 points here, right? So what you need to do is simple, right? Okay, as usual, a certain import and sklearn import data set. sample from here, random length figure, right? And we show, and so in this case here, we put k equals to 3. Okay, we put the k equals to 3. As for the cluster, is the random number, right? Generated a random number. Okay, so this is a random number generation, right? To find the cluster. Then we plot the scatter graph, right? And then we find the distance between point 1 and point 2. Okay, you can see here, we find the center point 0, right? And then after that, we find the center point 1 and 2. How to find that? We find the square root of the sum. Remember just now we take P1 minus P2 square, right? And then we assign the cluster in the range, right? Okay, so after assigning the cluster, then we update the clusters, okay? And we change it, and we define what is the cluster range, right? There you are. So you assign the cluster, and then you update the cluster range. Then you try to do precision. And then we plot them out as what you can see here, right? Okay, and that's what we show you. Okay, so this is called clustering. Okay. So small. There you are. So we have two clusters here, cluster 0 and cluster 1, right? And you can see here. Okay, how we divide them based on annual income and spending here. Okay, so that is the K clustering example. You will have in your tutorial the sample code are there. Okay, what I run there, I put in tutorial. Okay, any question before we go to hierarchical clustering? You know how it works? Okay. Okay. First, K equals to what first? You want 2 or 3, up to you. Or after that, you find the centroid. That means you take the average. And then after that, you find the mean distance using the differences. Then after finish already, then you try to see where they are closest and move your cluster. And that's it, right? And then you find that the equation is moved between the cluster difference. So that is the K neighbor. Okay, K nearest neighbor. That's why you call K and N. Okay, K dash and N means K nearest neighbor. Okay, to find who's the nearest neighbor. As for the calculation, no need to calculate because the algorithm will calculate for you, right? Okay, no questions. Then we go to hierarchical clustering, right? And this is to produce a hierarchy in which the nodes represent a subset of S. So hierarchy is something like a tree, huh? You always start with the root. Okay, the root is actually the whole input set S, right? And then the branching out will be the leaf, right? And then what called individual elements of S. So internal nodes are the unions of the children. I mean, which are you going to group them together? Which you are going to group, which node you have to group level together. So the level, how many leaves are there, how many nodes are there, will be the partition of input data, right? In a, what we call nest clusters of groups. What we call nest clusters of groups, something like that. So you can see here, A, B, C, D, E, F. So this is the one big set. There's the big set here. Then F and E is here. See, F and E is one set here, right? AB is another set here. Then after that, and AB will include another set C, here, and C will include D will include this A, B, C, D. Okay, D will include A, B, C, D, and then finally the root here will have E and F all together. So you can see that all these are subsection of C, and that is how hierarchical clustering works. Okay, okay. So this is how hierarchical clustering works. AB, right? See one node here, right? One level already, first level, the second level, third level, fourth level. So first level A and B together, one cluster, and then E and F together, one cluster. When you go to level 2, okay, then you have A, B, C, another cluster. See A, B, C, another cluster. Because this will form another cluster. Then we move up another level, then will be A, B, C, D, another level. See that? A, B, C, D, another cluster. And finally, we finish up to the root, whole thing will be a cluster. So all these are with one big cluster, inside we divide into many small clusters. And this is what we call hierarchical clustering. Right? So, how to start? So first, always place your S in its own cluster. We call that synchrone. That means you create a list of cluster L, initially the list of the tree, S1, S2, S3, and so on. Then you compute the merge cost function between each pair to find two closest cluster, which will be the cheapest couple to merge. Right? So you can see here, A and B is the cheapest couple to merge because they are the closest. E and F are the closest couple to merge because they are the closest. And then when we go to the next level of computation, you can find that C is nearer to AB. That's why they form the next levels of merging. And then after that, at the next level, they find A, next iteration, they find that D is closer to ABC. So therefore, they form another cluster. Okay, that's why they form another cluster here. Right? So sometimes we merge or we remove them until there's only one set remaining. Okay, that's one set here. Okay. So they are how to put the linkage between these two. Okay, between 2 points. How to do linkage? One is what we call single linkage clustering. The way we find the minimum, we call it connectedness or the minimum method. Right? That means the shortest distance from any member of one cluster to the member of the other cluster. So that's why we call it single linkage clustering, minimum method, right? The shortest distance. We also have the average linkage cluster. In this case here, we find the average distance from any member of one cluster to any member of the other cluster. So we find the average value. And your complete linkage if we find the maximum, right? The greatest distance from any number from one cluster to any member of the other cluster. Right? So minimum is used, okay? Okay? So single linkage, average linkage, and complete linkage. Complete linkage we make use of the greatest distance. Okay, complete linkage we make use of the greatest distance. Okay. Okay, let's say this example here, right? A set of data. Okay, assume that there are two clusters, C1 and C2. Okay, assume that K is 2 lah, in this case, two cluster, right? So we have two cluster, right? So cluster 1 will be A and B lah. And clusters 2 will be CDE. Okay, CDE, right? So to calculate the three cluster distance between C1 and C2, remember single cluster is the minimum distance, right? So the minimum distance between A and C, right? Okay, A and C, minimum distance between A and C, right? Minimum distance between A and B, minimum distance between A and E, okay? And then because this, so after that, then we find that two, right? So two, okay, and the other one two, CDE. So CDE. Okay, we only take out CDE, yeah. Okay, we only take out CDE. Okay, and the other one will be CB and C. Minimum distance two. D and B, minimum distance three. And four. E and B, D and E, minimum distance four. And so therefore, right? So we have 5, 3, 4, 5, 2, 3, and 4 minimum distance. And that is equal to 2. So between C1 and C2, right? Complete linkage. We find the maximum distance A and C, okay? A and D, A and E. Then after that, we find B and C, B and D, and B and E, right? And so therefore, we find that, okay, 5 is the maximum distance. See the 5 here? See the 5 here? 4, 3, 4, 5, 2, 3, 4, right? So 5 is the maximum distance. In this case here, 2 is the minimum distance. See the 2 here? We got 4, 5, 2, 3, 4, right? And 2 here is the minimum distance. Okay, got it? Okay, you know how to get 2, Look at here. 2, yeah, is the minimum distance. 5 is the maximum distance. Okay? Okay, that's how we get 2 and 5. After you find the minimum and the complete, and completely you find the maximum. Because the word minimum here, so you look for 2. And the maximum here, you look for 5. Okay? And of course, average, you take this 3, you find 3, 4, 5, 2, 3, 4. Okay, there's how many points? 1, 2, 3, 4, 5, 6 points. So there is 6 points. That's why it is 3.5. Okay, that's why it's a 3.5. So this is how you measure your cluster distance. It depends on what you use. Whether you use a single link, whether you use a complex link, complete link, or whether you use an average link. So single link, find minimum distance. Complete link, you find the maximum value. Okay, for average, you take everything divided by how many values are there. So that is how you measure your cluster distance. Right? So the algorithmic algorithm is carried out in 3 steps, right? One, okay, you start with objects and their measured features. Then again, you compute the distance matrix. Then you set that as a cluster. And how many clusters are there? One, and you know, then go on, right? And merge two closest clusters, right? So if there's ultimately you must form one big cluster. That's the rule. Ultimately, you must form two big clusters. That's the rule. If you don't form two big clusters, you can still plus two clusters, you merge them. Okay, that's why just now we merged all the smaller one until one big cluster. Then we update the distance matrix. We always merge the two closest cluster, and then you change update your distance matrix. That is algorithmic algorithm. Okay, so this is how it works here. Okay, we have algorithmic algorithm. So we have A, B, C, D, E, F. We have A, B, C, D, E, F. So we have A, B, C, D, E, F. And the data matrix 1, 1, 1.5, 1.5, 5, 5. Right? So you notice that here all is 0 lah, huh? Okay, because they are AA is not counted, DB is nothing, CC is nothing, DB is nothing, D and F nothing. Right? So the first thing we do AB. AB. So we take 1 minus 1.5 squared plus 1 minus 1.5 squared and square root. You got 0 point, there you are. So you got AB, then 0.71. Okay, then let's say we do DF, D and F, right? D and F is 3 minus 3 and 4 minus 3.5 squared. Then after square root them, you got 0.5 there. That's the distance matrix. Okay, you got distance matrix here. Okay, and this distance matrix is what we call Euclidean distance. Okay, we call that Euclidean distance. Okay, okay, how we add them up, right? So, okay, after calculating is what you will have, right? After calculating is what you have, and you find AB and DF. So merge the two closest clusters. That will be your first iteration, right? First iteration is DF. Just now you saw right, DF is right at the end, right? Okay, DN is right at the end. Okay, there you are. So DF 0.5. So here DF calculate to get the value, right? Okay. So then update the distance matrix. That's the first iteration. Do the same thing, and then update the second one. Do the same thing, right? Okay. Then you go on now, merge the same thing, do that again after you find AB, right? Okay, you find AB here, okay, and so on. Then you go second iteration, third iteration, same thing. I'm not going to calculate the math. So finally, you will have AB, DF, E, C, right? And then finally, you got one big group. Okay, finally, you got one big group, and that is the final iteration. And that's where you terminate, you stop doing. Okay, you stop merging, no more merging in this case here. And therefore, you can draw this out, you will get these 2, 4, 5, 3, and 6. Okay? And so you can see that we merge cluster D and F into cluster D and F at a distance of 0.5. Then at a distance of 0.5. See that? At a distance of 0.5. So we merge them at a distance of 0.5. Okay, and we merge A and B into AB at a distance of 0.71. A and B here, right? D and F, and A and B here, the distance of 0.71. A and B at a distance of 0.71. Don't forget, we are making use of single linkage. Single linkage means what? Minimum distance. Okay, when is how we learn minimum distance, right? We look at the single linkage. So we find the minimum distance. After calculated, already we find which is the minimum, we take the minimum distance. Okay? And so finally, we reach here, and all the object can be then you can conclude the implementation. Okay, this is what we call, so what happened coming here is what we call dendrogram tree. We call that dendrogram tree representation, right? Okay. So this will be the, okay, so lifetime versus K cluster. That means we take the difference between just now the demogram tree, the hierarchy clustering versus the K cluster lifetime. Okay, so we just take distance here. So what's the lifetime? Lifetime is the distance that a cluster is created and that it disappeared into two other clusters during clustering. And that is lifetime. Okay, so the lifetime of A, B, C, D, E. Okay, A, B, C, D, E would be 0.7, 0.7, 0.41, 0.5, 1, and 0.5. That's what we calculate just now. Right? Okay, so once we get that, right, we can just do 5 cluster with 0.71 minus 0.5. Okay, then we reduce that, right? So trees are the advantage of hierarchical clustering. Trees are good for visualization. So because it's easy to implement. Okay, hierarchical relationship between clusters are powerful and contain a real hierarchical relationship that would capture the concentric cluster. Okay, sometimes and there is no pure information. We do not know anything in a month. So we don't have the output at all. They have to compute and come to the output, right? About actually about how many clusters is in there. So it's not easy to define the level of cluster and identify the correct numbers of cluster by dendrogram. That's not the graph of dendrogram. It's not easy, okay? Experiments show that other cluster planning outperform better than hierarchical clustering because of sensitive to outer. Okay, outer means value that is very far away, right? Breaking large cluster and handling different size cluster in complex shapes and computation expensive. Why relativity of cluster? So because let's say given some data, any cluster algorithm will generate cluster. So we need to know that the cluster results are valid and meaningful. So that will involve what we call optimalities of cluster and the domain knowledge. Okay, that will depend on that. So what's the difference between k-means and hierarchical? Okay, so hierarchical cannot handle big data. Okay, k-means can. Okay, because time contracted k-means is linear. Hierarchical is quadratic. Reproducibility, can I reproduce the result? K means we start at a random choice of cluster. We choose randomly because we don't know what is K, right? So the result produced running the algorithm multiple many times, while the results are reproducible in hierarchical clustering. Performance work well, and the shape of the cluster is hypersphere. That means like 2D or 3D. But before what knowledge you have, K clustering requires before knowledge. That means you must know what is K. Okay, how many that means how to define the data, how many cluster you want, right? In hierarchical clustering, you can stop at whatever number of cluster you find appropriate just by looking at the dendrogram, right? So that is what we done. Okay, for double scan, we'll do it in the next lesson. Okay. Any questions? Okay. So you can see here, right? 3K equals to 3 cluster here, right? And you see the thing is, when you find the centroid is so far away, see the centroid so far away, right? Then finally you have to merge that, the center will merge inside here. See that? First, then the centroid will merge inside here. Okay, you can see the centroid was far away. Then later on, okay, it show them in the graph. Okay, that's how you show them. Show them in the graph. Okay, can we see first is something like this then when you define the centroid, it becomes something like this Why a centroid become like that the red color that's the centroid point Then after that it's fixed. Then after that all will find the mean here and fix the center point here. Then you find the triangle then you put them together. This you can do this in the tutorial. I don't know, I put it in B7 or B8. You can check. It's going to be highly technical now. But anyway, you no need to know how to calculate, just need to understand how it works, that's all. And then okay, sometimes mathematical no need to work. And no need to calculate because the algorithm will calculate for you. Okay, the algorithm will calculate for you. Okay, it will faster for you. Okay, last week I think I didn't show you the logistic algorithm. This is the plotting of the logistic algorithm. Okay, you see that? This is the logistic algorithm. Okay, 这是上课的哦，这是 logistic algorithm. Logistic regression. Okay, logistic regression. Logistic regression. And this is the linear regression. Okay, okay, this is linear regression. 这是全部在你的 notes 里面的。This is the linear regression. Last week I didn't show you. So now I will show you. Okay. Any question you can ask me. Okay, right now is 1:30. You go for your break. Then come back and do your tutorial.
Shit. Mouse is really stuck, guys. Let me see Google one. Just run the script. Let me run the script and see. Um, yeah. So you just put viral memes of SG. Then have to do the fucking research. Okay, so now I'm gonna upload this file. This one looks good. Huh? Let's see. I think I'm generating one video. Fuck. Okay, let's see. Okay, that looks very bad. Missing put values. No underscore values. is ready. Huh. You go to drive. Wait, where's my fucking drive? Where's my fucking drive? Where's my fucking drive? Where's my fucking drive? Let's let's put video one, video